Hello, you are welcome to this class. My name is Dr. Kingsley. In my previous class, I taught chemical kinetics. I explained what it means by the rate of chemical reaction. Equally, I also gave you the theories, okay, that explains the rate of chemical reaction. The theories such as collision theory, we have Arrhenius theory, and transition state what? Theory. I went further to give you the factors that affect the rate of chemical reaction. In my class today, I'll be taking you on, okay, rate law. Rate law, okay? I'll be taking you on the rate law. What is rate law? Okay, rate law tells us how the concentration of a reaction depends, how the rate of a reaction depends on concentration. Okay, now normally the rate law can be stated as this or thus. Rate law states that the rate of a reaction is proportional to the concentration of the reactant raised to some certain power known as the reaction order. The rate of reaction is proportional to the concentration of the reactant raised to some certain power known as what? The order of reaction. That is to say that if we have a reactant that is going to produce to give us the products, okay, this reactant we can use it to write the rate, because the rate law, in rate law, the rate depends on the concentration of reactants. That means the rate of this reaction will be proportional to what? Concentration of the reactant raised to some certain power. Let me use the power as x. Some certain power known as the what? The reaction order. That means that S is equals to reaction order. If you like, you can call it what? Order. Order of a reaction. Anyone you use is okay. Reaction order or order of a reaction. Now, reaction order is not the same thing as the what? Stoichiometric coefficient of the reactant, because the stoichiometric coefficient of this reactant here is 1. So you might be thinking that this x is equals to 1. No, you might have 3a, okay, to give us what? Products. Okay, our rate is proportional to concentration of A raised by what? X. The x here is not equals to 3, and the s here is not equals to 1, meaning that the order of reaction is not the same as what? The stoichiometric coefficient. However, there are some, okay, some instances where the order of reaction is proportional or is the same as the stoichiometric coefficient of the reactant. That is if the reaction is a one-step reaction. That is a elementary reaction. Now, some reactions take several steps. So the order of the reaction is the summation of the, okay, order of each of the steps summed together. However, some reaction takes only one step. That is one step reaction. For one step reaction, our reaction order will be equals to what? The stoichiometric coefficient of the reactant. So if I'm told that this reaction, okay, this to give this is a one step reaction, I will put 3 for my x. Okay, however, the reaction order can be obtained experimentally. We don't assume that it is the stoichiometric coefficient until we enter the lab. So it is determined through the what? The mechanism of a reaction. In my, okay, other teachings, I will give you how to determine, okay, the order of reaction, and as well as what? The reaction mechanisms. Now, I want us to know from here that what? If x here is equals to 0, the reaction, this reaction, will be called zero order reaction, because the reaction order is 0. If x is equals to 1, this reaction will be called first order reaction. If my x is equals to 2, this will be what? Second order reaction. Note, s can also be what? Fraction, and s can be what? Negative. can be negative. So we have what? Fractional order reaction. We also have what? Negative order reaction. Now, in this class, let us take zero order reaction. Now, we are taking zero order reaction. What is zero order reaction? A zero order reaction is a reaction that is in zero order. Okay? That means the reactions that the concentration of the reactant is raised to power of 0. So A gives us what? Product. We know that what? That the rate of reaction will be proportional to what? To concentration of what? The reactant raised to power of the order of the reaction. Now, since our order of reaction is 0, it means that our R will be proportional to A raised to power what? 0. And now, if we introduce a constant, our R will become equals to KO, okay, multiplied by A raised to power 0. This K is what? Is a rate constant. Rate constant. We are putting 0 here because it's a zero order reaction. So this is what? Rate constant for zero order reaction. Now, but we know that what? That A raised to power 0 or any number or anything that is raised to power 0 in indices is equals to what? 1. So 2 raised to power 0 is 1. 5 raised to power 0 is 1. So A raised to power 0 is 1. That means that my what? My rate of reaction will be equals to what? KO multiplied by 1. This is 1. So my rate becomes equals to what? KO. What does it mean? What it simply means is what? The concentration of the reactant have finally what? Disappeared from the rate. It simply means that what? The rate for zero order reaction does not depend on the concentration of the reactant. The rate for zero order reaction is constant. So when you take concentration against time at any particular what? Any particular point, okay, in the reaction, the rate will be constant. Now the rate of zero order reaction is constant. So if we plot a graph of rate against time, since rate is constant, the graph will be what? A horizontal what? Graph. Remember, when you write this, it means if this is rate and this is time, it means that the rate is increasing. If you put this way, it means that the rate is what? Decreasing. But if you put this way, it means that at this point, rate remain what? The same. It does not change. So the rate of zero order reaction is constant. So the graph of rate against time will be a constant graph. Okay? Where the line is horizontal. Now, having taken this, that the rate of reaction for zero order reaction does not depend on the concentration of the reactant, which is very what? Significant. Now we need to also know that we have what? Different types. That is types of rate law. We have different types of rate law. We have what? The differential rate law. That is A. Differential rate law. And B, we have a integral rate law. Okay, differential rate law is that rate law that gives us what? That gives us the rate of a reaction at a particular moment in time. It gives us what? The rate of reaction. So it is what? It is instantaneous what? Rate. It is instantaneous. Differential rate law is instantaneous. That is what? The rate of a reaction at a what? Particular point or moment in time. Now, the differential rate law, if you look at, okay, is the slope of what? Of rate, the slope of what? Rate time graph. So when we plot what? Our conch against time, okay, let's say our graph, I'm assuming now our graph goes this way. If you take the what? The slope of the graph, that will give you the instantaneous what? Rate, which is what? The differential rate what? Law. Now, the second one is what? B, integral rate law. Integral. The integral rate law is that rate law that shows us how concentration changes with time. Now, let us take the differential rate law for first order reaction. Now, we have A to produce a product. What is the what? The differential rate law. The differential rate law can be written as what? Minus change in concentration of A divided by change in what? Time. That is change in concentration over change in time. Like what I told you, when you have what? A concentration, okay, against what? Time. Okay? When you take change in concentration and you take change in what? Time. That is what? That will be the slope. The slope is what we call the what? The differential rate law. Now, why do we have minus or negative here? We are having negative here simply because that what? That the concentration of reactant decreases with time. That means that the final concentration of reactant is smaller than the what? The initial concentration. Concentration of reactant decreases with time. That is why the minus. Now, from rate law, we have that the rate for zero order reaction R is equals to KO. Then multiply by what? Multiply by concentration of the reactant raised to power 0 to show that what? That is a zero order reaction. If rate is equals to this and rate is equals to this, it means that minus the A over the T will be equals to what? KO, okay, into concentration of A raised to power 0. This thing we have here is what we call the differential rate law for what? For zero order reaction. And of course, you know that what? This is also equals to what? K. In fact, that is, this is also equals to KO. This is also equals to KO because A raised by 0 is what? 1 multiplied by K, that is KO. So this is our differential rate law. Now we want to go to integral rate law for zero order reaction. Integral rate law for zero order reaction. Now, integral rate law. Now, for us to have the integral rate law, we are going to what? Integrate the what? The differential rate law. What is the differential rate law saying? It is saying that what? Minus the change in A over change in time is equals to what? Is equals to KO. This is equals to this. Now, we want to integrate. So, if you integrate minus change in A over change in T, then integrate what? Integrate, okay? Alright, before I start integrating, let me cross multiply. If I have minus change in A, okay, to be equals to what? KO. When this multiply this, I have what? The T. Okay? And I want to what? Integrate minus change in A, okay? And integrate what? KO dt. You see that the negative will come out. Minus integral of the A, okay? Change in concentration of A will be equals to, you don't integrate what? Constant. So KO comes out. You have integral of what? dt. What are we integrating? From what? Initial concentration. We are integrating from initial what? Concentration of A to final concentration of A. We are integrating what? Time at T0 to time T. Integrating from where? The initial concentration to what? Final concentration. Integrating from TO to what? To a particular time T. Now, if you look at this, you find out that what? When you integrate change in A, it will give you what? A initial minus what? Minus A. That is what we'll have. If we integrate change in A, it becomes initial minus final, which is equals to KO When we integrate change in t, we get what? We get a t. Now, this thing you see here is what we call the integral rate law for zero order reaction. Integral rate law for zero order reaction. So this is integral rate for zero order. Okay? Now, we can make what? A the subject. We can make A the subject. If we make final concentration the subject, our final concentration, okay, will be equals to what? Will be equals to initial concentration minus, okay, Ko multiplied by T. This same thing. That is integral rate law for zero order reaction. Now let us have what? A plot. For example, if I want to rearrange this thing, I can rearrange it in such a way that my final concentration will become minus KOT, then plus what? Plus AO. What does it mean? I want to get a graph. That is why I am rearranging. If I want to get a graph of what? Final concentration versus what? Versus time. It's just like what? Y is equals to what? Mx, okay, plus what? Plus C. M is what? Slope. YC is what? Intercept. You can see that what? When we plot this again, this, we will have what? A straight line graph. We have what? A straight line graph. Straight line graph. Okay? This is a straight line graph. Whereby the slope will be equals to what? Minus KO. Alright? Why? The intercept C is what? Change in concentration. That is initial concentration. Not change, but initial concentration. So for zero order reaction, we have seen that what? If we plot our final concentration against what? Time, we get slope to be equals to minus K. We also get what? C, intercept, to be equals to what? Initial concentration. That is also very important. So the plot of what? Concentration, final concentration against time is a straight line graph. It's a straight line graph. Okay, the slope, the slope is negative. Since the slope is negative, the graph will go the other way. That is a negative graph. A negative graph. So that our slope is minus K, okay, and our intercept on the y-axis, intercept is on y-axis, is what? Positive. Okay, now please note this because it's very important. All right, now let us go to half-life. Half-life of zero order. Half-life of zero order reaction. What is half-life? Half-life is what? The time taken for the initial concentration to be halved. That means that at half-life, the final concentration becomes equals to initial concentration, okay, divided by 2. So at half-life, T is equals to T 1/2, and the final concentration becomes initial concentration divided by 2. Can you see? The time taken for what? For the initial concentration to be what? To be halved. Now, if we take this, we'll find out that what? That from the equation, final concentration equals to what? Initial concentration minus KOT. Let us now put A to be equals to this. This becomes equals to AO/2. So we are having AO/2 will be equals to what? AO minus KT. Okay, now this time now becomes half-life because A now final becomes AO/2. Now, what does it mean? We want to find what? We want to find T1/2 half-life. It means that half-life will be equals to what? AO minus AO over 2. Okay? Over 2. So, everything divided by, this is, remember, this is KO. Everything divided by KO. Everything over KO. Yes. So that means that T1/2, if we simplify mathematically, okay, the half-life will be equals to what? Remember, if you can find LCM of this, it will be AO, okay, AO over 2, then divided by KO. So this will become AO over 2 KO. So the half-life for zero other reaction, half-life, T1/2 for zero other reaction is the initial concentration divided by 2 multiplied by the what? The rate constant. That is what, where we are going. Now, in summary, what do we have? In summary, we should have that what? The rate, that is summary, the rate for what? For zero other reaction is equals to the rate constant, not dependent on what? On the concentration of the reactant. Then the rate, differential rate law, okay, differential rate law is minus the A over the T, which is equals to what? KO. Then integral rate law, integral, will give us what? A is equals to what? AO minus KOT. That is what? The differential rate law. Then half-life T1/2 is equals to what? Change, that is concentration initial divided by 2 KO. What are examples of those reactions that are zero order reactions? Okay, zero order reactions, a typical example is what? Enzyme catalyzed reactions. Enzyme catalyzed reactions at saturation. Okay, when the enzyme is saturated, is zero order reaction. Also, we also know that what? Photochemical reactions are also what? Zero order reaction. Now, thank you for this class. In my next video, okay, I'll be taking the first order reaction and the second order reaction. Remember, this class is very important, okay, for those who are preparing for AP, okay, those who are preparing for GCSE, okay, SAT, okay, UTME, okay, WAEC. First year students can equally higher levels, okay, but it's very important for beginners, okay. Thank you very much for this class. Always subscribe to my video, comment and like. Thank you very much.